Hello, everyone, and welcome to the first panel of the Nordic Data Science and Machine Learning Summit 2021. What we're going to be discussing here today is harnessing the full power of data science, machine learning, and AI functions, trends, challenges, and opportunities. With me today, I have Robert, Anders, and Daniel. We're going to start with a short round of introductions. So, Robert, why don't you kick it off with a short intro?
Thanks, Errol. My name is Robert Luciani, and I am CTO at Foxrane. I've been in this panel for many years now, and I'm good friends with everybody here, and really enjoy looking back at what we've said and what we're going to be talking about this year.
Great. Thank you so much. Anders?
Yeah, hi. Also an old guy. I've been doing AI for 20 years and in this panel a number of times, and know all the people here. Head of research at Peltarion, and actually starting some new adventures soon coming up as well. But perhaps we can leave that for later.
Awesome. Really excited to hear more about that. And Daniel, why don't you introduce yourself as well to the people listening in?
Yeah, thanks. My name is Daniel Tidström. Also been in the panel for a while. What I've been doing lately, I'm currently starting my own venture with some colleagues, so partner and management consultant at DataEdge. And previously, since last time, I've been at Epidemic Sound, building up a data science team.
Great. So it's been a really exciting year. Well, that might be the wrong word. It's been a really interesting year. It's been a really challenging year for many of us. We, of course, know that this has affected the event industry, and we couldn't meet physically this year. So why don't we do a bit of retrospective in the panel? I would love to hear a little bit about your challenges, the opportunities you have seen throughout the last year. So why don't we start with going back 5 years in time? And Robert, why don't you start giving us this retrospective? What have you seen the last 5 years within AI? Where are we going?
Oh, wow. In the last 5 years, it has gotten to the point where AI really is a discipline in its own right. And before it was owned by database administrators and that kind of thing, because, you would have these built-in functions that would do linear regression and that kind of thing. But now people are feeling that it's worth dedicating resources to. And I feel like that's the thing with all fields, where if you compare with the internet in the early 2000s, you would have one web dev guy that would be in charge of the e-commerce strategy, the website, and everything. And people used to think of the internet as websites. And now people are thinking of AI as more than just, these models. They're thinking of it as a strategy, and maybe you need more than one poor data scientist who's supposed to come up with both the business justification and program the model and put it into production. So I think people are a bit more mature about having it as a strategy and not just as an employee.
I think that's a very interesting observation. I couldn't more than agree. Anders, you've been in the industry for almost 20 years or even longer. What are some of the main things you've seen the last 5 years? And putting it into a larger perspective, where do you see that we're going with all of this?
I like the description that Robert gave as well, and starting to see AI as becoming more of a natural component in any kind of system. The whole holistic view of, what does it really take to operationalize AI? But, I'm a very techie person, and I also like to focus on the research in AI. So perhaps if I focus a bit more on that, otherwise I'm happy to talk about the other parts as well. But the research side, I think, is exceptionally interesting given the last 5 years. And especially, for 5 years ago, no one knew what a transformer or BERT was. And we weren't tired of all the kind of BERT alliterations, all the different variants of different names of BERT, like Alberta, Roberta, KB BERT, and so many more that we have today. And I think, one of the major highlights that we can see in the last 5 years from more of a research point of view is how the whole transformer-based revolution has transformed, what we can do primarily with text, but now starting to also revolutionize, what we can do with images and audio and time series and so many more things. So I think that's one clear trend. And another, perhaps unfortunate, but also a bit fun trend is the extreme upscaling of the size of data and models that we have today. So I'm thinking especially about OpenAI and DeepMind and the type of models like the GPTs of the world, and even going from initially in the transformer it was a few million parameters, then going a couple of hundred of million, then billion of parameters in GPT-2, and then hundreds of billion in GPT-3, and now it's even trillion of parameters in the recent models like the T5XXL and things like that. So it's kind of an interesting trend. But I think even more importantly, I think we can see how focusing more on operational aspects, focusing more on what type of models actually do work for practical use cases. GPT-3 is not something you want to use in your everyday business. But there are other solutions going more in the direction of what can you practically make use of the AI today, which I like very much. And perhaps just the two additional small areas in that direction. For one, focusing on the techniques to minimize the need for annotations. That is one of the major challenges for companies that want to use AI for real. It's not about increasing 0.1 percentage point on some kind of data set from academia. It's about how can you really find a model that works for you with your own data. And then all these kind of efforts with active learning and transfer learning and semi and self-supervised learning is really exciting. And you can do so many things with that today. Perhaps, if we mention one more, I think the whole neural architectural search area is actually very exciting. So normally you can see machine learning as a way to just automate the building of intelligent system, at least one part of it. So instead of manually defining the rules, you basically send in data and it can learn how to do predictions for a specific task. But you still have to define the whole architecture, and that's a very difficult and time-consuming and very much an exploratory trial and error type of process. But now with NOS and models like DART and GDOS, you can actually train not only the parameters, but actually the architecture itself at the same time as you train it. Not doing these hyperparameter tuning things or reinforcement learning outside in a macro search point of view, but actually training the architecture and parameters at the same time with very little extra time complexity added to it. I think that will be a big revolution going forward and really make AI available for so many more, and even us, poor data scientists that are trying to figure out, what type of layer should you use. We can simply learn that instead now, and I think it's really exciting.
So Anders, you're meaning I don't have to go through a research paper to find the optimal architecture. I can just trust the search type of function in the future?
Yeah, well, if I give an analogy to Spotify days, when I worked there, we had like a vision saying, in theory, you just want a single play button. You just go to Spotify, you press play, and it should play the music you want to hear right there and now. And in theory, you would like to see the same for AI. As a company, you just say, I want to have recommendations now for my retail, whatever kind of shop. Here is the data, press play, and it should find a way to design the model and make it use also in an operationalized setting with all the feedback loops, etc., and ML ops that you need to have there. We're very far away from being there, but I think that vision is very nice, and we have taken a number of steps to move closer towards that goal, I think.
Well, I'm definitely looking forward to that. That would at least support me in my recruitment efforts. It's hard to find the talent, and if we can get the technology to support that, I would be very happy. So, Daniel, how has the last 5 years been for you? What major observations have you seen in the trends going forward?
I think a 5-year horizon in this space is quite interesting, actually. I mean, just looking back on what I did 5 years ago, that was like developing a fairly bleeding edge system on Hadoop and sort of Jupyter Hub and notebooks, which was actually really cool at the time, and now it's totally outdated. That's sort of my reflection on 5 years. No one would do that today, even it was quite recently. So I think there is a lot of maturity. I mean, there first of all has been a major cloud shift that has sort of changed a lot of things. I see also that the maturity is increasing, and I think we see that also in the job market. I think it's quite interesting to look at the surge of data engineering right now. I think many companies have realized that sort of just crunching algorithms and trying to deploy them with a few data scientists probably doesn't work. We need to think more holistically about it and make sure we have good data of good quality as well. So I think we're sort of getting into a state where we're more focusing on actual, well, sort of have more knowledge of how to create actual business value. And I think that, I mean, both Robert and Anders mentioned that as well. I think that is a really, really good thing. Because I think, of course, our discipline and line of work, if we're not focusing on creating business value, we will end up having trouble in the future. So I think that's really good. And yeah, I know we're going to discuss a bit about roles emerging as well. So I'll keep it at that for now.
No, but I think that's also a great summary. I usually say these days, if I were doing the same things and having the same opinions I had 5 years ago, I would probably do on-prem Hadoop still. So it's good to see an evolution into more modern technologies. So I think it's very good. I think all three of you have different perspectives, but you see in a similar direction. We're moving quite fast and we're getting out of the lab, and now we're actually pushing the AI-driven transformation of companies. We're starting to see the value coming out of these investments. That also means that, picking up on what you said, Robert, the different roles, we are starting to see more clarity. It's not just about the jack of all trades, trying to be the software engineer, be the data engineer, be the modeler, be the person that's responsible for all of these aspects. So what we're starting to see now is more the emerging of more people entering the field, not primarily a technical background, and the technical backgrounds going into a more specialized setup. So I would like to leave this as an open question to the panel now, so we can have a bit of a discussion. What roles are you seeing in this new emerging field of AI, which I see is the more broader discussion?
I just want to say one thing about what Anders was talking about before, about all the BERTs and that kind of thing. I mean, I think BERT, and perhaps even more GPT-3, it's funny that it's such a technical term for a specific deep learning architecture, but it's still a fairly somewhat well-known term. I mean, you'll hear people that are not machine learning experts, they know what GPT-3 is. And that's the first good sign that you have non-AI people talking about AI specifics. And you don't have to know how GPT-3 works. That's not the point. And we were talking about applications of AI in sort of non-conventional areas. And one of my favorites now is AI Dungeon, which is a game that uses GPT-3 to generate a role-playing scenario with text. And I think that's super creative to have, you don't need to be an AI expert to come up with that kind of an idea. So like the key role in the coming years is going to be people that understand the potential of AI, but can be a little bit more creative about the business cases. It's unreasonable to expect the data scientist to do all that stuff. It's going to need to be business savvy people. And the fun thing was, I saw a tweet from John Carmack just the other day saying that he has an NVIDIA A100 with 80 gigs of RAM that he was very happy to be playing around with, and that he wished he had that when he was doing the mega textures stuff with the Rage engine. But like, Anders, if you have an 80 gig GPU in your home workstation, you can do quite a lot on your own. And I mean, there's nothing to suggest that it's going to stop in the coming years. It's ridiculous how the hardware is going to be increasing, I think. Yeah. It's special what you as an individual can do. That's what I think is most inspiring about computers in general. And so organizations...
Do you mean you don't have an 80 gigabyte GPU in your drawer?
Mine only has 40.
Guys, I think we're getting a little bit off track here.
The thing is, like organizations, you don't need to be this mega organization anymore. You can have a person that has a good business idea, and you can get pretty quick about implementing it. So Google and the others are not necessarily 2 or 3 years ahead now. They're maybe 6 months ahead or 12 months ahead. I don't know. What do you think?
Oh, that's a strong statement. I wish I could agree with you.
I think they're ahead in research, but maybe not in, like, I don't think anybody can come up with GPT-3, but for sure people could implement something of similar capacity.
Yeah.
So and then just a follow-up question on that. I mean, they might be 12 or 36 months ahead, but does that matter? Is their way of implementing AI the same way as we see in traditional companies, potentially here in the Nordics? When we talk about these type of roles, I'm going to throw a few things at you here. AI translator, business experts, data analysts, data scientists, deep learning engineers, data engineers in general. we start seeing more and more job ads for these type of specific roles for traditional companies that are seeing that we need more specialized things. What are your ideas here? Are we going the right directions, or should we just keep it simple and have a data scientist and then have them specialize in different things? What are your opinions? How are we seeing the development in the job market of roles?
I think for sure that from my perspective that it's a good thing that it clarifies a bit, because I've experienced in some cases that there is a sort of reality gap between sort of what an individual data scientist sort of would like to do and what they actually do at work, and that's not a good thing for anyone. So I think that the split between ML engineering, which is like probably very focused at building and deploying and running actual products, like any software engineering position, is good, while data scientist, I think, at least where I've been, is moving more into providing business insights, but often, of course, with the help of an algorithm or a sort of AI methodology. But I think that is good. But also, I really welcome the search of data engineers as well. I think that is really, it's so important. I mean, that's the food for any model you build, is the data. So I kind of like that. But I like that it's moving more to creating business value, and that everyone should really focus on that, because it's nothing sort of creates value unless it's sort of applied in the right place with some kind of objective in mind.
And Robert, you have a team of very specialized people working both on the product and with your clients as well. How are you seeing this interaction with the companies you are interacting with? What are they asking for when they come to you?
I have to admit, I haven't heard the word AI translator before today, but I think like the key thing that unlocks projects has been the ideation stage. The great thing about all the different roles is the ability to sort of execute with consistency, I think. But there's nothing like being able to unlock, sit there and say, did you know this is possible? Did you know this is possible? And then people say, can we actually solve this using AI? And you're like, yeah, we probably could. But I feel like people don't get past that stage. One thing I'm very passionate now is about geometric deep learning, which is really catching on in research. And geometric deep learning is very abstract, but it's very applicable to business processes, but it's not obvious how. So you need somebody to sort of, maybe that is the AI translator that translates abstract ideas to applications. I think that role is I don't know if customers are even asking for it, but I think that's what they need.
Yeah, no, definitely.
But also one just a question to the panel. Because I think that we also need to train our business layers on AI at some kind of rudimentary level to actually understand the basic forms of AI and how it can be applied. Not building it, but identifying the use case, like where can this be solved? Because having sort of often centralized units trying to like be the innovation engine for a whole enterprise, that doesn't scale. So I think we need to reach outside that and actually implement people. I know at Epidemic Sound we had, I don't remember, but there is some navigation course from Anders probably know about AI that you can attend. So we basically decided that everyone in product and tech are sort of encouraged to attend that course to really understand what it is, because it's that important for the company.
And I agree with that. And I think most companies that we see today, especially the large one, are launching some sort of data and AI literacy type of upskilling program. We're launching one now in H&M. I read the other day that Levi's were also launching one where they had people internally applying, upskilling and teaching them how to become data scientists and machine learning engineers. And we start seeing more and more of these. Anders, do you have some input on this as well as a final note before we go to the next topic?
Of course, I always have an opinion, you know that. But very much agree, and I'm glad you brought that up, Daniel, and you, Rob, as well. Although I agree that we see an increasing specialization in different AI roles, I think it's the wrong direction. And I think it's not a sustainable direction. And I don't think it's what truly scales AI. What truly do scale AI is when it becomes a natural part of any kind of person, role, or division of the organization. So I think instead of trying to just have 15 different AI roles and people, instead try to incorporate that as the natural part of the business and the service, but also in the people's skills. So the CEO and management team should know what AI is, and take, for example, the Elements of AI course that you mentioned. Although it's not perfect, it's still better than nothing, and it's free. And all the engineers, etc., should start moving towards understanding and being able to use AI. Today, of course, software engineering, traditional software engineering, is rather different from AI engineering. But we are seeing a lot of initiatives also in research right now trying to unify these, trying to say that the tooling that we have for normal traditional software engineering should be including also the AI part. So we have a similar level of maturity for AI engineering tooling and MLOps, etc., as we do have for traditional software engineering. The day that will happen, that is when we can truly scale and operationalize AI. And I think we're moving rather quickly in that direction. And I think that's a much more sustainable way to go.
So great segue, Anders, because the next topic is operational AI. So let's start with that. Anybody want to pick up the torch here and explain what is operational AI?
I can just continue, I guess, since you forced that on me, more or less. Well, if we try to see what a lot of research, at least, is doing right now, especially from the large tech giants and OpenAI, DeepMind, and also Facebook and Microsoft, etc., and Chinese companies, is, at least from a more research point of view, that focus on these questions of how can we increase 0.1% on some kind of academic data set. And they use even larger and larger models all the time to be able to do so. And that's interesting, I think, especially from a more philosophical point of view. And if you think about the vision that DeepMind and OpenAI has, which is to build AGI, then it makes perfect sense, and it's awesome. But it's rather different from the type of research question that we need to be able to make use of AI in industry today. And that is more what operational AI is focusing on. So trying to identify what are the major challenges in preventing companies to use AI today. Why are so many companies ending up in the AI prototype graveyard, which is a nice topic or concept, I think. Yep. And trying to see things like, why, for example, can't people annotate data properly? And how can we minimize the need for annotation and still be able to have a well-functioning AI model? I think that's a typical operational AI question. And how can we find models that work in a scalable way, both from a memory and time point of view, and perhaps also on the edge and whatnot, and perhaps also take in consideration data safety, like how do you work with sensitive data from ASIN journal texts, and using techniques like federated learning, perhaps, or differently centralized techniques. This is operational AI. This is focusing on questions that truly make companies be able to use AI for their own use cases and data set. And I think it's a very important research area that I wish more people were focusing on. And I'm stealing a bit from Jeremy Howard. He also said famously on a Lex Friedman podcast once, I think most research in deep learning is a complete waste of time. And then he listed, a number of these techniques that we should be focusing on, which is, transfer learning, semi-supervised learning, and active learning, and these kind of things.
That's a super awesome segue, because I want to hear a little bit more of your thoughts on one thing. So you said semi-supervised learning or self-learning, and I've found one thing that customers have a very hard time doing is sort of understanding, not necessarily AI, because they know that an AI can study something and then make prediction based on its understanding of that thing. But data modeling is very hard. Like, how should we annotate data? Can this model learn using self-learning, or do we have to use supervised learning? And sort of setting up the problem as a data structure seems to be the hardest part. And I'm thinking this also ties into the teaching everybody what AI is. I wonder if those courses are very focused on, neural networks and models, as opposed to how do we collect data? What kind of data would you need to train a supervised model and that kind of thing? And so for operational AI, maybe the reason people aren't coming up with good operational ideas is because they have a hard time conceptualizing their business processes as data processes.
That's a very good point. Daniel, what are your thoughts on operational AI?
It's a hard question. It's a very big question. I mean, it's obviously the important thing. I mean, it's as we say, it's a huge sort of it's like that quote of that the future is already here, but it's not evenly distributed. Some companies are very far ahead and has a lot of these processes set up, but a lot of companies are still struggling with working with these things. And it's so many aspects. It's the technology and like algorithm aspect, but also organizationally and roles. Sort of how do you set it up to not only build and deploy, but to actually run model and monitor like data drift and retrainings and versioning. So there are so many things that probably in some areas needs to work differently. So I think, I don't know really what the trend is, but sort of at least at Epidemic Sound, which I saw Carl Tomes here to speak about something, you can probably tell more about, but really trying to get it into the product teams to like trying to see, as Anders said also, ML and AI is a tool to solve problems or to build products, and it's slightly different in how you do it, but you should sort of look at it the same way. And there needs to be ownership, there needs to be maintenance and like life cycle management and those things. But I think there is a lot of things happening, at least in the domain with like both data ops and ML ops, which sort of takes it in the right direction. But I mean, obviously, totally super important. If we don't have operational AI, what do we have then?
Yeah,
non-operational AI.
I think that's very interesting. And I think we have some really good presentations throughout the conference on MLOps, for instance, and the technologies to do these type of things. One thing I want to pick up on here is you mentioned life cycle thinking. I remember a few years back when we did the first proof of concept, we started productionizing and we left it in production. But as you also mentioned around data drift, there's a life cycle to models. Things change, data shift, and the reality around it makes the model not a good representative of that reality. Could we expand a little bit around the life cycle thinking? And we're also getting a question here about A/B testing. How can we incorporate that into a life cycle thinking to ensure it? Should we start with you maybe, Anders?
The question then about the A/B testing specifically, you thought, or what was the question? I mean,
so the life cycle thinking in general, and then trying to close that loop as well with how does A/B testing, potentially multivariate testing, fit into a life cycle thinking? I know it's throwing a bit of a curveball here, but that's why we're here.
Yeah, I'm trying to find a good holistic view of this. Of course, trying to think more holistically about not only the model, not only the data pipeline, but actually putting it into a system and integrating that. And then we have the normal kind of system development with a lot of A/B testing that is done to basically ensure that we have the best user experience that we can have. And if we can then include AI in that, which we should, as AI is becoming increasingly unified into the normal software engineering process, then of course we can do like A/B testing on the different algorithms that we try to do. But that's like a halfway there. I mean, we can imagine a more long-term future where we don't have to do as much A/B testing because we can simply train and learn with the data we have directly. That's a rather long stretch goal. I think a good step would simply be to first integrate AI into the normal kind of life cycle that we have in the product development that we have, and incorporate also, of course, the A/B testing that we otherwise do together with different changes in AI models. As long as we do that, and we can see, for example, how the quality of different recommender system predictions are, and what really works in practice and what does not work, when you optimize something offline or in batch mode, this is really what, for example, Spotify did a lot when trying to see, which recommender system does really the user like the most. And there is no other way but to do proper A/B testing to really find that out. but to have a more holistic view on that so you can actually continuously do that. So, we have a term that we use for an upcoming AI engineering workshop in late of May. And we have, the traditional kind of CI/CD, continuous integration and continuous delivery, but we could also add CT to it, so continuous training. So the point on the day that we had not only CI/CD, but also CT, CI/CD, CT, I think that will be a beautiful future where we just see this kind of feedback loop that continuously improves the user experience of whatever product you're building.
Yeah.
Bit fluffy answer, but I hope.
Can I add some comments on the A/B testing thing?
Yeah, go ahead, Daniel.
My passionate areas. I think definitely that you should close the loop with A/B testing to see how does the model perform in the wild, in real life with actual users. Obviously, I think you should do that for all software that you build. But also to Anders' approach, I mean, looking at how you can enable experimentation with the help of machine learning and AI or just algorithm is also something that I encourage. Like A/B tests are hard to scale because they're sort of manual and they don't really evolve. They're sort of static over some time window often. But looking at sort of bandit algorithms or contextual bandits or even reinforcement learning, where the system actually optimizes itself over time is super interesting. And that's a totally different ballpark when it comes to scalability. And I think not just addressing the term, but actually the concept. Well, why do you want to run experiments? And that is, of course, to have a better sort of product or web page or whatever you apply it on. And scaling out that sort of learning process is super interesting. Yeah. Also a bit of a fluffy answer, but look at it from two directions, basically.
It's a fluffy topic.
Because you can do like A/B testing on machine learning, but you can also do machine learning or on A/B tests.
Yeah, sometimes I'm imagining people from the outside listening into these type of discussions that they would have no clue what we're talking about. Time is running very fast when you have fun. So Robert, do you have just a short reply or remark on the operational AI lifecycle thinking?
No, not so much. I think it's been covered by Anders and
So we have a comment here from Errol. He's asking, is this a maturation thing? Machine learning components are strong tools adding to the toolbox of software development, just as operational data has already been, and what it adds in inferring probabilistic approaches to use of the operational data to software solution. So in that perspective, we're actually mostly talking about software development, but we need to harden the data inferring probabilistic data-driven capabilities for software developers to make use of it in a serious way. I think that's a very good comment. What are you thinking about Erik's input to the discussion?
Well, I can firstly agree that the tooling around AI is, of course, very much immature compared to traditional software engineering. And data has been around for a longer time, but to use data for AI purposes is still very immature as well. And the tooling around that is very much lacking. And I still hope and believe that it will not be too long in the future when we actually will have much more mature tooling. This is what we are working hard with at Peltarion to try to provide, to bring AI into the hands of the many and to not have to have specialized, AI people and roles, but really, when you can have domain experts, some domain expert that perhaps understand the data around like a machine that can do floor grinding or something, or around some retail business or manufacturing company, whatever it is. The people that truly understands the data are the people that understands the domain. And we've seen that time and time again, AI scientists coming in and saying, I think we should build a model for this use case. And then the domain expert come and say, I think this have a much bigger potential. And they are almost always right. So if we simply can enable domain experts to themselves drive the AI initiatives and how you transform the data and use the right type of data, I think that is really the day when we can truly scale AI as well.
Super. I think that was a very good comment. Thank you. So we're moving on a little bit here in the agenda since time is running out. What about the data? Since now we started to bring it up. Is it still a problem, you would say? How about the data-centric versus model-centric? Robert, any comments on that or explanation to what I mean with data-centric versus model-centric?
I don't know. This debate has been around since the early 2000s, in sort of the shift between the model-first approach of statisticians and the data-first approach of Andrej Karpathy's sort of follow the data where it takes you software 2.0 style approach. I think that ties into what Eric was saying about this being a kind of software development or software engineering thing where you need to let the data lead you. But the problem is, for us, it might be who are machine learning practitioners, it might be obvious what the data has in terms of potential, but it might not be obvious to everybody. So I think when it comes to data versus model first, it's important to give people the tools, not necessarily to develop the machine learning models, but rather to formulate the problems. I think one of the key unlockers of actually getting AI working the way we envision it are these education programs that you're talking about and setting them up right.
Daniel, you started bringing up educational programs, I think. Any comment on Robert's remarks?
Yeah, but I agree as well. I mean, the two, I mean, data-centric or model-centric, I don't know. Can you pick both? Because I mean, it's quite important that you need to have some tracking of the data to ensure that you have quality and stuff like that. It is sort of, it converges at least the discussions we're having now at my current assignment, where we have both data scientists and data engineers in the same team. It's really like, how can we build pipelines that are really end-to-end, and how do we monitor data drift or model drift and these things? And it's an interacting system. And I think there are quite interesting tools coming up now with, I mean, dbt, for example, for scaling data engineering or analytics engineering. I think it's a very interesting tool. It's very sort of test-based and then a lot of engineering practices in it. But also frameworks like Great Expectations are really good, where you can set, this is my expectations on the data set that I'm working with, and it will automatically sort of quality assure what you're working with. So I think to me, that is part of the operational AI, that you need to set up a holistic framework where all the pieces work together in a holistic system. Otherwise, if you have weaknesses in the system, it's gonna cause problems, and it's likely to end up as a blame game.
So we have 3 more minutes. Sorry for interrupting you, Daniel. I just want to take the final question here to the panel. And sorry, Mikael, for your question not being able to answer it. But I just want to talk about the future trends. You have 30 seconds each to do a bit of forecasting into the future. I know, Anders, you usually say that forecasting is hard, especially about the future. But what will we be talking about next year's? 30 seconds each before I do a bit of closing. Starting with Daniel.
Okay. I see a shift in where we spend the money, basically. We had a period of hiring data scientists and trying to figure it out that way. Now we see it shifting into data engineering. My hope and thinking is that it's going to shift into business to really become a part of doing business. And it needs to be on the vocabulary of most people. You don't have to be able to code yourself, but you need to understand how it can be applied. You need to think about sort of AI first and looking at this sort of business process. Can it be solved with the help of ML or AI?
Thank you.
I hope that is the trend that we will see.
Great. Anders, 20 seconds.
Okay, so 2 major topics or trends. I think one is the traditional long-term philosophical research in AI and trying to develop AGI and just scaling up models. It will continue to happen, and they will do that. But I think it will be a significant improvement and scaling up in terms of operational AI, and really trying to focus on the problems that make AI provide value. So trying to see how DevOps and MLOps can be unified more and more, and how data engineering becomes a normal part of any kind of software development process, and moving towards more truly operational AI is something I think we will talk much more about coming year.
Thank you, Anders. Robert, 10 seconds.
10 seconds. We're going to see geometric deep learning gain traction because it can be applied to all sorts of abstract things. And we're going to see reinforcement learning being a big thing because people can't figure out how to get the data working. So we're going to see Facebook Dino and that kind of stuff figure it out on their own.
Thank you so much. It's been a pleasure as always. Thank you so much all for listening in, and make sure to reach out to me if you want to take to set availability and book meetings with people, and also reach out if you want to have the presentations being done in the opening keynote. Thank you so much. Take care. See you in 2022 or later on today. Take care.
Bye-bye.
Bye.